So let's do a couple more examples for arithmetic sequences. This will be a very typical example, i.e. hint, hint test question. Has a lot of other elements to it that we've done. So it kind of lends itself to a good question. So, question is, find the general term or nth term of the arithmetic sequence. So it tells you it's arithmetic. That's kind of important. So you don't have to guess. It's saying it's arithmetic. You have to know that. We also know if it's arithmetic, we get automatically this formula or nth term. A sub n is equal to a sub 1 plus n minus 1 times d. So we automatically get that. Okay, and then it gives us the 15th term and the 27th term. They want us to find this first and then use it to calculate a sub 500. So that's the goal. Usually I want to give you a big enough number you're not going to do it by hand because that's not the point really. So what you do is you look at A15 and A27 and write down everything you know about those things. So we have A15 is equal to A1 plus, and then it's n minus 1 times d. But our n is what? It's 15, like that, exactly. And then let's move this over a little bit. And then we know a sub 27. So a sub 27 is a1 plus, and then 27 minus 1 times d. But what is a sub 15? The actual number. The actual number is 49. So we can say 49 equals all that. And then similarly, for A27, it's 85. So we're going to say 85 equals all this. And then so that's what you set up. So what you get, go away, okay. So A15, so this was 49 equals A1 plus 14D. And 27 was 85 equals A1 plus 26D. And so now, put that in this form. So check this out. A1 plus 14D equal to 49. And then A1 plus 26D equal to 85. What does that look like? Right here. That is a 2x2 system of equations, which we just did in the previous chapter. So this is your equation 1. This is your equation 2. Do you see why this lends itself to a good test question? Because it's using other forms of things we've done. So now the goal is to figure out, for arithmetic, you need to know A1 and D. Once you know A1, the first term, and the common difference, that's all you need to figure out the nth term. That is the components of the nth term. N is your variable. So we just solved that. So you may want to take a second and solve that on your own and find A1 and D. So I would just subtract those two, E2 minus E1. And if you do that, you get 12D. It turns out real nice, you'll see. Equal to 36. So D is equal to 3. Okay, and once you have that, just as before, back substitute for A1. So A1 plus 14 times 3 is equal to 49. And then we just solve. So A1 is equal to 49 minus 42, which is 7. So your first term is 7. So now you calculate the nth term. So the nth term is going to be a sub n equal to the first term plus n minus 1 times d, which was 3. And then you simplify that. So distribute the 3, combine like terms, etc. So you get 7 plus 3n minus 3 equal to 3n plus 4. And so that's a sub n, that's your nth term, that's your function that determines each term of the sequence. That's the idea. And then use this to calculate a sub 500. Otherwise, you'd have to do 500 terms of the sequence, which I've seen some strange things before, but I don't want you to do that. I want you to use the function a sub 500, 3 times 500 plus 4. So 3 times 500 is 1500 plus 4, so it's just 1504. It's not an O, it's a 0, but okay, fine. So it's a 0. So 1504 is the 500th term of that sequence. Okay, so that was an example. We're going to go on now to summations, or the sum of an arithmetic sequence. Okay, so next thing here, and let's go ahead and just go to the next page. Makes my pages look a little better. Not example, sorry. So this is, just write down, this is the sum. I'll move this all the way up. Of an arithmetic sequence. So we want to add up the terms of an arithmetic sequence. All right, so take a look at this. So we call the sum S sub n. Okay, let me back up here. Let me do one more thing here. Okay, so let's let A sub n be an arithmetic sequence. Okay, so we know we have the form A sub n is A1 plus n minus 1 times d. And I'm going to rewrite that somewhere else because it's too cramped. So A sub n is A1 plus n minus 1 times d. Okay. We're actually not going to use that, but just that's what we have. All right. So, and then we're going to say, suppose S sub n is the sum of the first n terms of the sequence. So S sub n is A1 plus A2 plus A3, etc., plus all the way to a sub n. So that's what it will look like. Now we're going to rewrite a2, a3, all the way to an in the form of basically a1 plus d, or a1 plus d plus d. We're going to do that again. All right, so this is equal to a1 plus d plus a1 plus d plus d plus, and you keep going in that manner, plus all the way to a sub n. We're not going to write that one out. All right, so then what we're going to do is we're going to write, so that's s sub n. We're going to flip it around. Now go start with a sub n, and then write the previous term. So the previous term is basically a sub n minus d plus a sub n minus 2d. So actually, let's move this down. I'll do one more step because I needed that here. So what we're going to do is write s sub n is a1 plus d plus a1 plus 2d plus etc. all the way to a sub n. So if you keep going in that manner, you get to all the way down to a sub 1. So we can see here that these d's are all going to annihilate each other all the way down. So you add those two equations and you get 2s sub n is equal to basically n of the a1 plus a sub n's. So there's 1, 2, 3, all the way to n of them. And all the d's have canceled essentially. So then you just divide by 2 and you get n over 2 times a1 plus an. So the sum of the first n terms of an arithmetic sequence is the first term plus the last term times half n, half the number of terms you're adding. Okay, so you'll have all these formulas to look up, so it's not like you need to memorize it, but I want to show you how we find them. So this is what you need to know. See if I can make that onto a box. No, I didn't do that. Every time I try to do this, it seems to not work. Okay, better. So write this down. This is the sum of the first n terms, specifically of an arithmetic sequence. It's also called the, in case you read the book, the nth partial sum. Nth partial sum is what that's called. So let's look at an example. Find the sum of the first 50 terms of this arithmetic sequence. So find the sum of the first 50 terms of an arithmetic sequence. So this is one of those things where the whole point of this is to follow the, don't actually add them up by hand. That's missing the entire point of the exercise. It's understanding how to apply the formula. So that's what I would want you to do, obviously, here. But sometimes it's tempting just to add them up, but I want you to use the formula. All right, so the sequence is this. It is 1, 5, 7, 9, ... Common difference D we can see is 2, and it's arithmetic. So we want to say S sub 50 is equal to 50 over 2, right? Do we all see where we got 50 from? 50 is your n. All right, and then we know the first term. And what else do we know? And it's the first term plus, well, we don't know a sub 50. Right? We don't know what this one is here. Well then, what are we going to need to do? So we need to find it. We need to determine, right? We need to determine what it is. We need to find a sub 50. So we go back to our formula. We go back to using the nth term of the arithmetic. So we use that. So a sub n is equal to a sub 1 plus n minus 1 times d. And so we can calculate that. It's basically 1 plus n minus 1 times 2, which is the common difference. So it's 1 plus 2n minus 2, or 2n minus 1. Which should make sense, right? What type of numbers are those? Those are odds. Well, it's every other odd. Oops, I wrote it out wrong. I was like, it is odds. I forgot the 3 there. So 1, try that again. 1, 3, 5, 7. So those are the odds. So 2n minus 1 are the odd numbers. If n is 1, you get 1. If n is 2, you get 4 minus 1 is 3, etc. Okay, so these are the odds. All right, so now calculate a sub 50. So a sub 50 is equal to 2 times 50 minus 1, 100 minus 1, which is 99. So we go back to our formula. S sub 50 is equal to, we'll just write 25. And then it's 1 plus 99, which is 100. So it's 25 times 100. And so that's just 2,500. 2,500. 2,500 is the sum of the first n terms, or 50 terms of the odds. You add up all the odd numbers, you get 2,500, all the way to 50 of the terms. Okay, that's 8.2. So both of these questions are really important. These are the ones starred are the ones that are most important. That one and that one. And the rest is just kind of warm up understanding. That's it for 8.2. We will go on to 8.3 next, and that is on geometric. So 8.3 is on geometric sequences.